All right, we're on page number 3 of our study guide for today. Aaron and Blake both wrote down equations. Their equations had the same slope, but Aaron's y-intercept was negative and Blake's y-intercept was positive. How many solutions would their system of equations have? Explain your reasoning. Well, anytime that they have the same slope, so again, it was important to notice that it said right here, they had the same slope, but their y-intercepts were different. It means they would be parallel lines, okay? Anytime the slope is the same, the y-intercept is different, they're going to be parallel lines. And if they are parallel lines, it means they will never intersect, so it will be a no solution. Okay, same slope, different y-intercept means parallel lines, which means it is a no solution. In the next 4 problems, we just need to determine the number of solutions it will have. Okay, in this one, well, because they're both not in the same form yet, we're going to make them in the same form. So I'm going to turn this first one into slope-intercept form by subtracting 6x from both sides. So that leaves me with y equals negative 6x plus 8. And now if you notice, these two are identical because they are now the exact same equation. It will have infinitely many solutions. It would be the exact same line if you were to graph it. Okay? In our next one, these are the same, right here, same. These are different.
Do you have any questions? You can ask them.
Those will never be the same, so this is a no solution. All right, in our next one, looking at this right here, they have different slopes, different y-intercepts, so we will just have one solution. Anytime the slopes are different and the y-intercepts are different, you will always have one solution. Now in this one right here, if we were to take this top one and multiply everything by 3, you'd have 3x plus 3y equals 18. So these end up being exactly the same. So this would be infinitely many solutions. Infinitely many solutions. All right, going down to the next couple problems. A jar of quarters and dimes has a total value of $20.70. The jar has 10 more quarters than dimes. To find the number of quarters and dimes in the jar, Addison wrote the following system. Explain her error. All right, so it says she has the same number of quarters and dimes. So in this case, she has x being your quarters and y being the dimes. So if you look right here, x is 25 cents, that's a quarter, y is 10 cents, that's a dime, and so that equals our total right here. But in the second one, it says the jar has 10 more quarters than dimes. So this is saying the number of dimes is 10 more than quarters. So she switched it. It should have been x is equal to y plus 10 instead, and then she would have been able to solve it. Again, we don't have to solve it though, I just wanted us to explain what the error was, and she just switched her variables. That's also why it's really important to always label your variables when you're doing something like this. And the next one, Brody went on vacation and purchased postcards and stamps to send letters home while he was away. 2 postcards and 4 stamps cost $3. So we need to figure out, in the first one, the postcards. That's going to be our first variable. Our second is going to be the stamps. All right, in our first system of equations, He said he bought 2 postcards, so that's 2x, and 4 stamps, so that's 4y, and it cost him $3. The second one, it said a postcard is 4 times as much as a stamp. So x is 4 times as much as our stamp, which is y. Set up a system that could be used. Oh, okay, there's our system. Do you notice it says do not solve? So that's as far as we have to go in this.